All right, ladies and gentlemen, welcome back to the Athenian Stranger tutorial videos, where today we are going to be looking at a geometry problem that asks us to find the length of a line segment given the coordinates of its two endpoints. Okay, so this is one of those deceptively simple problems. It's easy to say it, it's another thing to find it. Find distance AB given that A is located at -4, 1 and B is located at 3, -1. I want to take you through the whole thing and show you this time. If you watched my last video, you know that I found the distance using the Pythagorean theorem, which kind of derived the distance formula. This time I'll take a more literal approach to the idea of teaching the distance formula and show you how to come up with that formula from the graph. So first, we're going to create a little graph here. We're going to do it quickly so you can see that it is possible to draw graphs quickly, right? It might not look as pretty as something that you spend a lot of time on, but it can still be accurate and useful. All right, so as you watch me do this, I'm going to visually do it. Usually I use the ruler. This time I'm going to visually do it. So I'm just going to create some little hash marks here. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. I'm trying to do the best I can to space these out the same, just using kind of eyeballing it. 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Okay, that should be good enough. Now let's plot point A. So point A is composed of an x coordinate and a y coordinate. The x coordinate is -4. So I start at the origin and go left 4, -1, -2, -3, -4, and then I go up 1. So that point A is right there at -4, 1. Put a dot there and call that A. All right, where's B? It's at 3, -1. So back to the origin. The x coordinate is 3, the y coordinate is -1. So I go origin 1, 2, 3, then down 1, right there. Okay, so here is B. And it's asking us to find this distance right here. Okay? It's asking us to find the distance between those 2 points. So how do we do that exactly? Well, again, I highly recommend watching the previous video so you can kind of follow along with my thinking here. Let's ask ourselves, well, let me do it this way. Let me show you the distance formula, and then I'll tell you how it's derived. So here's the distance formula. It is the square root of the squared difference in the x's plus the squared difference in the y's. Okay, now if you watch the previous video, I hope you can appreciate why I didn't just drop this formula on you and say, oh, plug in the numbers and just solve it out, because that just doesn't generate any visual understanding. In many cases, the book doesn't even draw a graph, and I think it's very important to kind of see it visually. So let's figure out exactly what this means. Okay, so I'm going to go back to my graph here and take you through this thought process about how triangles are hidden in these pictures. So here, I'm going to create a right triangle by completing the triangle here. Okay, and now let's talk. Let's talk about the difference in the x values. So what is the x value at B? The x value at B is 3. Okay, so this is 3. The x value at A is -1, -2, negative 3, negative 4. Okay, so this is negative 4. Those are the x values. So let's go back to this formula and see what we're doing, exactly what we're doing. So let's replace those x values. We're taking the square root, open parentheses, and now it says x2. Well, maybe we should label these points. A is giving us x1 and y1, and B is giving us x2 and y2. Okay, so let's look. X2 is going to come from the B point, which is right there, 3. Okay, so we saw that visually, that the x-coordinate of point B is 3. So let's write 3 minus, and then here is the x1 coordinate, which we identified as the x-coordinate of point A. So 3 minus negative 4, close parentheses, squared, plus. All right, now let's work on the y values. Come over here and say, well, what is the y coordinate of the B point? Well, see, the y coordinate of the B point is located at negative 1. So that's negative 1. And then what's the y coordinate of the A point? 1. Okay, so I want you to let's visually do this. What is the distance on the vertical axis here between negative 1 and 1? We'll just count up negative 1, so 0, 1. So 1 hop, 2 hops. So the absolute difference here is 2. The absolute difference here is 1, 2, 3. Okay? 1, 2, 1, 2 hop, 3 hop, 4 hop, 5 hop, 6 hop, 7 hop. Let's see if any of this comes up when we work on this formula here. First, let's plug in the values. Y2, whether we look at the B coordinate, which is negative 1, or we look over here at the coordinate pair itself, we look for Y2, we put negative 1 right here. Minus Y1, okay? Whether we look at the picture or the coordinate pair, you see that the Y1 coordinate is 1. So we put a 1 right here. These are subtracted, so at least in this case, we're going to have 3 minus 4. Two negative signs become a positive sign. So when we rewrite this again, we'll get rid of that. It's the square root of, open parentheses, 3 plus 4, close parentheses, squared, plus, open parentheses, what's negative 1 minus 1? Let's see. Negative 1 minus 1 is negative 2. Negative 2 squared. And we've still got to clean this up. Let's do this one more time here. The square root of 3 plus 4 is 7. 7 squared plus, open parentheses, negative 2, close parentheses, squared. Okay, let's talk about this for a second. In the previous video, I said this term, absolute difference. I asked you for the absolute difference. So I didn't say 3 minus 4, because that doesn't make any sense. I asked you to tell me how much space is between these 2 points, and you counted 1, 2, 3, 4, 5, 6, 7. So your brain knows that there's 7 spaces between these 2 points right here on the x-axis, and that there's 2 spaces between the 2 points on the y-axis. Your brain knows that. Okay? So over here in the distance formula, the problem that confuses students a lot is that we have this negative number here. You say, well, wait a minute, I thought you said there were 2 places, but my math tells me there's negative 2 places. Well, let me ask you a question. Can there be a negative distance? Can you drive a negative distance to the store? Can you run a negative distance on the track? No. Okay. Can you throw a baseball a negative distance? No. Right? So geometry deals with the world of physical things. And so in the physical world, right? In the physical world, there's no negative distances. So here's the good news. This little formula here is going to take care of that, because it doesn't matter if you square a negative number or square a positive number. They're both going to be the same squares. Think about it this way. What is 2 squared? It's 4. What is negative 2 squared? Well, negative 2 times negative 2. A negative times a negative makes a positive. Negative 2 times negative 2 is positive 4. So it really doesn't matter that there was a negative number here, because by squaring it, you're going to get a positive number every time. So again, it's not ever going to matter whether you've got a negative number in these parentheses. When you square it, it'll be positive. Let's do that now. So what is 7 squared? I'm going to rewrite this again. Take the square root symbol here. We're still working with this under the square root symbol. What's 7 squared? 7 squared is 49. Plus, what's negative 2 squared? Negative 2 times negative 2 is positive 4. Okay, so put a 4 right there. 49 plus 4. One more time here. Square root symbol. And you tell me, what's 49 plus 4? 53. Okay, so square root of 53. Okay, now it's time to analyze the number underneath the radical sign. Let's talk about 53. Can we factor 53? Well, let's see. Let's do our little test. Remember this from last year? I said add the digits and see if those digits are divisible by 3. We know they're not divisible by 2 because the ones place has an odd number. So we have to move up one prime number. Okay? So what prime number is bigger than 1? 2, it's 3. So let's see. Is this divisible by 3? 5 plus 3 is 8. Is 8 divisible by 3? No. So this is not divisible by 3. Is it divisible by 4? No, it's an odd number. How about 5? Let's see. We have to look here. Is this a 5 or a 0? No. 6 is an even number. 7. Is it divisible by 7? Well, 7 times 7 is 49. 7 times 8 is 56. So no. How about 9? 9 times 5 is 45. 9 times 6 is 54. Nope. 10 even. 11. It doesn't end in a 1. 12 even. 13. Okay, is it divisible by 13? That one's harder because you don't like have that in your head. So what's 13 times 2? 26. What's 13 times 3? So just add 13 to 26. 26, 36, 37, 38, 39. 13 times 4, 39 plus 13, 39, 49, 50, 51, 52. Okay, 13 times 4, 52. That's not 53. So it's not divisible by 13. Okay, so what else could it be divisible by? 15? Nope. It goes to 45, then it jumps to 60. 16, 17. Could it be divisible by 17? 17 times 3 is 20. 17 times 4, oops, I'm sorry, 17 times 3. 17 times 3 is 51. Okay, so no. So we're running out of numbers, you see. So here's the thing. We've done this in our heads. We've worked it out. 53 is a prime number. So 53 is prime. It cannot be factored. Because 53 is prime, the answer, if you're going to write it exactly, you would say this. You would say AB is equal to, so the distance between A and B is equal to the square root of 53. Now, if you put this in your calculator, it's going to give you a decimal, but that decimal will always just be an approximation. Okay? Let me show you this here. Clear the deck, take the square root of 53. 7.280109889. It never repeats. Okay? So we'll just approximate it out to a couple of digits. So we'll write the squiggly lines here is approximately equal to 7.28. Right? You'd have to ask your teacher to what number of significant digits, but it's 7.28 is approximate to 3 significant digits. Okay, so that is the answer to this problem. The distance between A and B is 7.28, right? I've always found it easier to use the Pythagorean theorem and draw these triangles, to the consternation of many teachers, and I don't care because I think it's more intuitive. That said, if you found this method more intuitive, please make sure to like this video, leave a comment indicating your joy and mirth at seeing this video, and make sure to ring that notification bell so you're always alerted to new videos in the future. Thank you very much.